Lesson 40, ratios, proportions, and similarity. Wait, it's lesson 41. Did I say 40? Ratios, proportions, and similarity. Okay. So a ratio is comparing two numbers together, so it's kind of like a division problem. So some examples of ratios, you could do the colon, which you read A to B. You could do A to B and it looks like a fraction. Or you could use the word to for A to B. And that shows your ratio. A proportion is a statement that two ratios are equal. So 2/4 equals 1/2. That is considered a proportion. When we have a proportion, the numerator of the first and the denominator of the second are called extremes. So A and D are extremes. And B and C are called means. And then if you guys remember from previous years, the cross products of a proportion are equal. So the product of the extremes will equal the product of the means. I'm going to show you how to write a ratio that has more than 2, which I didn't realize. Since it's comparing numbers, that makes more sense. Okay, so these two triangles are similar. And this is RST UVW. We're going to do 7, 9, 13 and 14, 18, 26. So we want to write a ratio comparing the lengths of RT to TS to SR. So without the line, that means we want the lengths. So we do RT 9, TS is 7 to 13. And you can write it this way. Writing it with the division bar wouldn't look right because there's 3 numbers. So you could use the colon. I guess you could say the word 2, 9 to 7 to 13. Comparing WV to UW in 3 ways. So we're going to write the ratio of WV to UW in 3 ways. Whoops, I guess I wasn't supposed to put the overbar on there. Forgot. Because we're just talking about lengths. Okay. So it's 14 to 18, but you can reduce to 7/9. So we could go 7 to 9. 7 to 9 is a fraction, or 7 to 9 with the word 2. So another example might be, show that RT to UW is equal to RS to UV. So when we're showing this, you can write a proportion with the 2 ratios. So we have 9 to 18 equals 13 to 26. Since they both reduce to 1/2, you have a true proportion. Samuel?
With the 14 to 18, is that part of what we were just barely looking at? Is that something?
This thing, from this example,
Yeah.
yeah, it's, all of these examples are from this example.
Okay.
And now we're going to go over to similarity. So we've got ratio, we've got proportions, we've got to learn the we've got to learn extremes and means, because in a lesson to come we're going to talk about those. Similar polygons they're the same shape and they may be the same size, but they don't have to be. And of course they're polygons. In similar polygons, the corresponding angles are congruent and the corresponding sides are proportional. We do have a transitive property of similarity. So similarity is transitive. So if one figure is similar to another, and then that other figure is similar to an even another figure, then the first one is similar to the third one. So we'll write that using A and B. So if A is similar to B, and B is similar to C, then A is similar to C. And this little squiggly line is similar to. You know when the congruent sign is so cool, you have an equal sign with a similar sign above it. So this means all the lengths are equal and the figures are.
It's the same as not though, right?
It's, wait, which is? Oh, yeah. Yep, we use it for not. And is there anything else? Yeah, not yet.
We kind of use it for approximate, but
Oh, yeah, it's also approximate. Huh.
Well, isn't approximate two of them?
Oh, yeah,
it is two of
it is two of them. Yeah, okay.
So how did that happen? Like similar to, and then when there's two of them, it's approximate.
Oh, it's like it's not exactly equal, so
It's similar
they
to?
similar, yeah. No, it's a morphed equal sign. Like,
Yeah.
it's approximately, but not exactly equal to.
Yeah.
I don't know.
Okay.
Okay, so we're just super quick gonna do one example with similarity. We have this figure EFGH. Whoops, I didn't quite do it right. Oh well. EFGH. EF is 6 units long and HG is 80 degrees. And then we have ABCD, another figure. Angle B is 130 degrees, AB is 12, BC is 18. Now you want to look at the order of the letters. So we're going to say ABCD is similar to EFGH. So what are the measures of angle F and angle D? So if you look at measure angle F, it's a second letter, so it corresponds to angle B, and because they're similar, the angles will be the same. So the measure of angle F is 130 degrees, and the measure of angle D, which is the last letter, corresponds to H, which is 80 degrees. So measure angle D would be 80 degrees. And then what is the length of GF? Which word do you need? Angle D, measure angle D. So you can do a proportion. You can have EF, so 6 is to AB, so 12 as EF. Oh, I already did that. EF to AB as BC, so 18. Whoops, I did that wrong. So I did the smaller figure in the numerator here, so I have to do the smaller figure in the numerator here. So GF is the smaller figure, so GF is to CB, which is 18. Since this reduces to a half, GF would be half of 18, or 9 units. Okay, that's all I'm going to write in the lesson.